Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous video, I was actually teaching the 10th chapter of 9th standard science subject that was on work and energy. And I have completed most of the concepts which are there in this particular chapter. So in this particular video, I have left some examples in this chapter. So those examples I'll be discussing. So coming to the example 10.3. So example 10.1 and 10.2 are discussed in my previous videos. You can refer that in the work video where I have explained what do you mean by work done. So there I have explained example 10.1 and 10.2 as well. So please refer that video for 10.1 and 10.2. From in this video, we'll start from example 10.3. So in example 10.3, what they're asking is that you have to calculate the kinetic energy of an object. So here the data which they have given is velocity is equal to 4 meter per second and the mass of this object is equal to 15 kg. Now you have to calculate kinetic energy of this object. So kinetic energy I'll just call as EK, that is equal to half mv square. So what is m and v? M and v are the mass and velocity of that particular object which is in motion. So now mass is 15 kg and velocity is 4 meter per second. So everything is in SI unit, so directly I can substitute the values here. So 4 square. Now you have 1 by 2 into 15 into 4 4s are 16. So 2 1s are 2, 2 8s are 16. So 15 into 8 is remaining. So EK, that is kinetic energy of this particular object, is 15 into 8. So 15 into 8 is 120 joules. So 120 joules is the answer for this particular example 10.3. So whenever this particular object which is 15 kg, when it is traveling at 4 meter per second, then it possesses 120 joules of kinetic energy. So now coming to example 10.4, here there is a car. So here they have given a car which was initially traveling at 30 kilometer per hour speed. So that means here initial speed of this car is 30 kilometer per hour and final speed, like that means this car has been accelerated and it has reached some final speed and that final speed is equal to 60 kilometer per hour. So now they have given initial speed and they have given final speed. So here they have given the mass of this particular car as well. So the mass of this car is 1500 kg. So using this data, you have to calculate work done in reaching 60 km per hour speed from 30 km per hour speed. So that means this car has increased its speed from U to V. So in this process, what is the work done? So in this process of increasing speed from U to V, that is from 30 km per hour to 60 km per hour, what is the work done? You have to calculate here. So in the video where I have explained about kinetic energy, in that video I have explained how work done is equal to difference in kinetic energy. So according to that, work done is equal to the final kinetic energy minus initial kinetic energy. That is the difference between the kinetic energies initially and finally. So initial kinetic energy, final kinetic energy. So I'll write this as EKF minus EKI. So EK means it is kinetic energy and F is final and I is initial. So final kinetic energy minus initial kinetic energy will give you the difference in kinetic energy when it reached from speed U to V. That is the work done. So that's why work done is equal to difference in kinetic energy. So this particular equation we have, or you can write this as work done is equal to what is initial kinetic, what is final kinetic energy? Final kinetic energy is half m. Final speed you have to take V square. So here also initial kinetic energy will be half m u square because initial speed is u. So half m v square minus half m u square will give you the work done. So before calculating this, we have to convert the speed which is given in SI units. So here they have given speed, the initial speed as 30 kilometer per hour. So here this is not in SI units. So that's why now you have to convert this to SI unit. So in order to do that, you can replace this K with 10 power 3. So when you do that, 10 power 3 is nothing but 1000. So 1000 meter per hour will be there. Now if you want to convert this per hour to per second, you have to divide by 60 into 60, because in the place of per hour, so hour will be in the denominator, you can write 60 into 60 seconds. So that means here those many seconds are there in 1 hour. So 1 hour contains 60 minutes, and each 60 minute where 1 minute contains 60 seconds. So based on this, when you multiply 60 into 60, you will get 3600 seconds as your answer. That is equal to 1 hour. So always remember 1 hour is equal to 3600 seconds. So here hour is in denominator. So in the place of hour, I will write 60 into 60, that is 3600 seconds. So now here 1010 gets cancelled with each other. Here also 110 gets cancelled with each other. Now you have 30 into 10 divided by 6 into 6, that is 36. So 30 into 10 is 300 divided by 36. So now 3 ones are 3, 0, 0 will be remaining. Here 3 ones are 3, 3 twos are 6. Here 2 5s are 10, 0 will be remaining. 2 6s are 12. Again this can go with 2, 2 25s are 50. Here 2 3s are 6. So you are getting initial speed as 25 by 3. You have to calculate the final speed. So final speed they have given as 60 kilometer per hour. So if you convert this to meter per second, then you have to multiply this with 1000 and divide this with 3600. So then you will get this as meter per second. So here also 2 zeros gets cancelled with each other. So 60 into 10 is there. So V is equal to 600 divided by 36. Here also this can go with 3. So 3 twos are 6. 200 will be remaining. 3 ones are 3. 3 twos are 12. So similarly this can go with 2. So 100 will be remaining. In the denominator 6 will be there. This can go with 2. So 2 50s are 100. Here 2 3s are 6. So this is equal to 50 by 3 meter per second. So now you have got initial speed as 25 by 3 meter per second, and now you have got initial speed as final speed as 50 by 3 meter per second. So now we can go to this formula, work done is equal to half mv square minus half mu square. So work done is equal to half, in the place of m you can take this mass. So mass they have given as 1500 kg. So now in the place of m you can substitute that 1500. In the place of v, that is the final speed, you got that as 50 by 3. So 50 by 3 whole square will be there, minus 1 by 2. In the place of mass you can take 1500 into, in the place of initial speed you can take the initial speed value, that is 25 by 3 whole square. So now you have 1 by 2 into 1500 into 50 by 3 whole square minus 1 by 2 into 1500 into 25 by 3 whole square. You can take 1 by 2 into 1500 common in this. So work done is equal to 1 by 2 into 1500. So in the bracket, in the big bracket, you have 50 by 3 whole square. So 50 by 3 whole square means 50 square by 3 square. So 50 square is 5 5s are 25, 2 zeros you have to put because 1 0 is there. When you make square of that, it will become 2 zeros. So 25 and followed by 2 zeros. So that is 2500 divided by 3 square. So 3 square is 9. Similarly, 25 by 3 is there. So 25 into 25 is 625 divided by 3 into 3 is 9. So now you have 2500 by 9 minus 625 by 9 in the big bracket. So first you can solve that. So in this particular equation you can see denominator are same, so no need to take LCM, directly you can subtract the numerator. So work done is equal to 1 by 2 into 1500. So inside bracket there is 2500 minus 625 divided by 9. So now 2500 minus 625 is 1875. So work done is equal to 1 by 2 into 1500 into 1875 divided by 9. So now you have this. Here 3 3s are 9, 3 5s are 15, 0 0 will be there. So here 3 1s are 3, 3 6s are 18, 3 2s are 6, 1 will be remaining, 15 will be there. So 3 5s are 15. So 625 is there. Work done is equal to, here 2 500 and 2 are there. So 2 1s are 2, 2 2s are 4, 1 will be remaining, 10, 2 5s are 10, 1 0 is there. So 250. So 250 into 625 is there. So now when you multiply 250 with 625, you will get the answer as 156250. So that is 1,56,250. So work done SI unit is joules. So 1,56,250 joules is the work done in order to increase the speed of car from 30 km per hour to 60 km per hour. So when the car speed is increased from 30 km per hour to 60 km per hour, the amount of work done in increasing that speed is equal to 1,56,250 joules. Coming to example 10.5, here they are asking to calculate potential energy of an object which has mass 10 kg and from the ground level it is 6 meter above. So now here they have given acceleration due to gravity as 9.8 meter per second square. So here you have data, that is mass of an object that is equal to 10 kg and the height at which this object is placed is equal to 6 meter and the acceleration due to gravity g is 9.8 meter per second square. So now potential energy formula is equal to, so I am writing that as EP. So EP is potential energy is equal to mgh. So potential energy is equal to 10 into g is 9.8 into h is 6 meter. So everything is in SI unit, so directly I am substituting the values. So 10 into 9.8 is equal to 98 into 6. So 98 into 6, 6 into 8 is 48, 4 carry, 6 into 9, 9 6 are 54, so 54 plus 4 is 58. So 588 joules is the potential energy possessed by this object when it is kept at 6 meter high from the ground, when that particular object is having 10 kg mass. So the potential energy is equal to 588 joules. Coming to example 10.6, here they have given mass of an object. So mass of an object is equal to 12 kg and they have given the potential energy possessed by this object when it is kept at a certain height from the ground. So we don't know what is that height. That height you have to calculate. So here they have given potential energy that is equal to 480 joules and they have given the acceleration due to gravity as 10 meter per second square. So whenever they give acceleration due to gravity value, that value only you have to take. So in this problem they are specifically mentioning to take acceleration due to gravity as 10. So we can take acceleration due to gravity as 10 meter per second square. So potential energy formula is equal to mass into acceleration due to gravity into height. Don't know what is height, so you can keep height in the RHS, bring mg to LHS, it will go to the denominator. So EP divided by mg is equal to height h. So here height h is equal to EP by mg. So what is EP? EP is potential energy, that is equal to 480 joules. So this is also in SI unit. So directly I am taking values of EP, m and g. So m is mass, that is 12 kg, into g is 10. So here 1010 gets cancelled with each other. So 12 ones are 12, 12 fours are 48. So 4 meter is the height at which this object is kept. 480 joules because of its 12 kg mass, because it is 12 kg massed object which is kept at 4 meter height from the ground. So it is possessing 480 joules potential energy. Coming to example 10.7, here there is two girls. So the girl one name is A and the girl two name is B. So there are two girls named A and B. So both of them climb a particular rope and reach 8-meter high level from the ground. So now girl A takes 20 seconds time to reach this particular 8-meter height, and girl B takes time 50 seconds to reach that particular height, that is 8-meter height. So now you have to calculate power expended by both of these girls. So how much power both of these girls have put in climbing that rope to reach 8-meter height, you have to calculate that. So now in the first case you are considering girl A. So girl A has reached height 8-meter in time 20 seconds, and here they have given common weight for both of these girls. So weight is always equal to mass times acceleration due to gravity. So that is mg, that is equal to 400 Newton. Here they have not given the mass, they have given the weight. So weight is nothing but mass times acceleration due to gravity. So mg. So now we don't know mass, but we don't need to bother about mass. Here we want to calculate power expended by each of the girls. So now both of them weigh 400 Newton weight. Here you have to calculate power. So power formula is work done by time. So work done is nothing but potential energy, because here they are reaching certain height. So that's why instead of taking work done, I can take potential energy. So here we have to calculate work done. So the formula for work done is mgh, because here they are reaching certain height. Here we are taking work done as mgh divided by time, that is 20 seconds. Because here they are reaching certain height, potential energy possessed by those two girls after reaching that height has to be considered. Means that much amount of work done they have done to reach that height. So that's why work done is nothing but potential energy. So here we can take work done as potential energy, that is equal to mgh. Now power is equal to mgh by 20 seconds. So here we don't know what is m, but we don't know what is g, but together mg they have given here, that is 400 Newton. So directly in the place of mg you can substitute 400 Newton. So 400, it is in SI units only, so I am just writing the value 400 into height is 8 meters, so 400 into 8 divided by 20. So for girl A, power expended is equal to 400 into 8 divided by 20. So here 0 0 gets cancelled with each other, 2 1s are 2 2s are 4, so 20 will be remaining. So 20 into 8 is there, so P is equal to 8 2s are 16, 1 0 is there, so 160 watt. So now if we come to the second case, here girl B, we have to calculate how much power is expended by girl B. Here also you can take, so here also weight of this girl is equal to 400 Newton only. So weight is equal to mg, that is equal to 400 Newton, and height is same, that is 8 meter, but time is 50 seconds for girl B. Now power is equal to mgh divided by t. So mg, so this together mg is weight, that is equal to 400 Newton. So you can substitute 400 into height is 8 meter divided by time is 50 seconds. So here 0 0 gets cancelled with each other, 5 1s are 5, 8s are 40. So 8 into 8 is 64. So P is 64 watt. So that means power expended by girl A is equal to 160 watt, and power expended by girl B is equal to 64 watt. So coming to example 10.8, here there is a boy who climbs up a stair. So there are stairs like this, so 45 steps are there. So there are in total 45 steps, and a boy takes 9 seconds to reach the top of this floor. So that means he has climbed that 45 steps and reached certain height. So you have to calculate how much power this particular boy has expended, and the data which they have given here is the height of each step is equal to 15 centimeter. So like this he has climbed 45 steps. So that means the total height is equal to 15 centimeter into 45. So 15 centimeter into 45 means this 15 centimeter I can convert to meter, that is 0.15 meter into 45. So when you do 45 into 0.15, so that is 15 5s are 75, so 7 carry, 15 4s are 60, 60 plus 7 67. So after two decimals you can keep the point. So 6.75 meter is the total height which this particular boy has climbed, and mass of this particular boy is equal to 50 kg, and here he has taken 9 seconds time to reach that particular top. So now here he has done that much amount of work to gain that potential energy to reach that height, because when that boy reaches that height he gains that much amount of potential energy, and that potential energy is the work done by that particular boy. So that means here in the place of work done I can take potential energy, because in power, while calculating power we want work done by time. So work done by time is nothing but potential energy divided by time, that is equal to mgh divided by time. So here they have given acceleration due to gravity as 10 meter per second square. So in the question they have exclusively mentioned take acceleration due to gravity as 10 meter per second square. So whenever they mention like that, you can take whatever the acceleration due to gravity given. Whenever they don't mention, then you have to take 9.8 meter per second square. So here they have mentioned 10, so we can take 10. So P is equal to mass of this boy is 50 kg. So now we can substitute these power values here. Here they have given acceleration due to gravity as 10. So 50 into 10 into 6.75, that is the height, divided by 9. So that is the time, 9 seconds. So now when you calculate this 50 into 10 into 6.75 divided by 9, 375 watt, because the SI unit of power is watt, so I can take capital W. So 375 watt is the power expended by this particular boy. So this is all there in this particular video. The exercise questions which are there in this chapter, I will be teaching that in my subsequent videos. Like this, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.